Here's an example in which we're taking an expression secant minus cosine over secant, and we're simplifying and writing the trig expression in terms of sine and cosine. So we're going to rewrite each of these three parts in terms of sine and cosine, and then we're going to simplify. So let's go to our formula sheet. Here's our formula sheet, which it tells us all the sine cosine stuff. Here's secant. Notice it's 1 over cosine. Tangent is sine over cosine. Cotan is cosine over sine. And cosecant is 1 over sine. All right, so with that in mind, let's do it. So I'm going to grab this secant right here. What was secant? 1 over cosine of t minus, and then cosine. That's just cosine. Nothing needs to be changed about that guy because he's already a cosine, right? We're making everything sine and cosine. He already is. And then the bottom, the secant, what's he going to be? Again, he is 1 over cosine of t. Okay, now we need to simplify this. This needs to be simplified by us. So that's actually even the more tricky part, is how we simplify this. So let me erase some of these arrows so we have a little bit of room here. So how do we do it? Let me write you a note here so it doesn't seem so mysterious. Excuse me, what I'm about to do. When we have fractions over fractions. See how that's what we have here? We have a fraction over fractions, right? It's called a complex fraction. When we have fractions over fractions, I'll write the name if that helps you. It's a complex fraction. Fractions over fractions. Okay, what do we do about it? Multiply all the terms, top and bottom, by the LCD over 1. And the LCD, let me mention, the LCD equals the 1 of every type of item under a bar. Hope you got that. So the LCD is 1. It's only 1 of every type of item under a bar. What am I talking about? Well, this is under a bar and this is under a bar, right? Aren't those the only things under bars? I don't mean the main big bar. I just mean under maybe I should say a small, under a small bar. So yeah, what is under a small bar? This cosine and that cosine. Do I use them both? No, 1 of every type. So I just use 1 of those. That's the LCD over 1. So in our case, the LCD is just cosine. Cosine of t over 1. Cosine of t over 1. And cosine of t over 1. See how I did that? I did LCD. See what it did, like it said right there? LCD over 1. The LCD is just cosine. It's not both of them, right? Again, you just use 1 of every type of item that's under a small bar. So I just looked at the items under the small bars. They're both the same. There's just a cosine. I only use 1 of them. And so I put that over 1, that over 1, that over 1, multiplied all the terms, top and bottom, by the LCD over 1. Now that's totally legal to do. It's not illegal. The math cops will not come for you because you're doing the same thing to the top and the bottom of the fraction, right? So you're not changing it. We're not changing the fraction. You're doing the same thing to all the terms on the top and the bottom. So when you're done, it'll be the same value it was before. It'll just look different. Okay, well, how will it look? Well, these will cancel, and these will cancel. So on the bottom now, go back to this here. On the bottom now, we just have 1, don't we? Because these canceled. Here, these canceled, and we just have 1. And right here, we have minus cosine squared. because it's cosine times cosine, right? And the 1 on the bottom doesn't matter. See how I ignore the 1s on the bottom? You know that, right? You know that 7 divided by 1 is just 7, right? Just think about division. What's 10 divided by 2? It's 5, right? Because 2 goes into 10 5 times. Well, likewise, 1 goes into 7 7 times. So my point is, having 1 in the bottom of a fraction is, you can ignore it. It does nothing, right? 7 over 1 is just 7. And cosine, and this stuff right here, 1 over 1 is just 1, and 1 over 1 is just 1, and cosine squared over 1 is just cosine squared, right? So in the same way, right here, this just becomes 1 minus cosine squared, because that 1 on the bottom is irrelevant. 1s on the bottom don't change anything, we ignore them. So this is 1 minus cosine squared. Now we're almost done. You might think we are done. We're almost done. You have to recognize this. This has to be something in this section. This is a very challenging section. In this section, this guy needs to jump off the page or the screen for you. Let me show you on the formula sheet. There he is. 1 minus cosine squared. What is that? Sine squared. See, all it is, it's the Pythagorean identity, and they just subtracted the cosine squared to the other side. So it's just a different version of the original. So anyway, when you see 1 minus cosine squared, you got to know it's sine squared. Or if you see 1 minus sine squared, you got to know that's cosine squared. All right, let's go back. So that means this is equal to sine squared. Sine squared. 1 minus cosine squared is just sine squared. Now, you might think, okay, so the answer here is sine squared. Almost. Here's the trickery. They already gave us the 2 power right there. They're saying, hey guys, we know there's a 2 power. Don't tell us about the 2 power. That's what they're saying. They put the 2 power already there. You see how they wrote it? They're saying, hey, we already know there's a 2 power there. There's going to be a 2 power. We just want you to tell us what's inside of that 2 power. So then our answer is just the sine. Even though the answer to the question is sine squared, they're already giving us the 2. They're saying, we know there's a square there. We know that. Don't bother telling us about that. Please just tell us what the F is. They're calling it F. That's just a name. They could call it Joe. They could say, tell us what Joe is. Joe is underneath a square power. Well, what's underneath a square power? The sine. The sine is what is under a 2 power, right? So they just want the sine. The 2 power is already there. It's kind of a funny way that they're doing it. So our answer is just regular sine, because they asked us, tell me, when they gave F, it doesn't matter. They're saying, tell me what is underneath the 2 power, sine.